Hey, this video is on a lecture that I did Friday, January 18th on linear models. And it's going to be the same two examples I did in class. I'm just posting it to, help out anyone who wants help. So first example from the book, Fitness Club charges initial fee of $165 plus $24.95 per month. So a couple hints on these linear model questions. When it says per anything, that's telling you that this is really a rate. And I could rethink this as $24.95 over months. So the rate is going to be your slope. So I know that's M. The other one is charges an initial fee of $165. So I go in and buy a membership, and then I don't go. I am out. That's gone. That's my initial amount. Initial, starting, all that is telling me this is the y value of the y-intercept. So if y equals mx plus b, that's the b. So part A, formulate a linear model that models the total cost of C of t of a club membership for t months. So we have to be aware here, typically in class we have y equals mx plus b. Now we're going to end up with C of t equals mt plus b. The x's are going to become t's. Y is being replaced by this function notation. So if I unblock the answer there, C of t is equal to 24.95t. I know that's going in front of the variable because it's the slope, plus the y value of the y-intercept, 165. So that's our linear model. That's what we would use to predict if I go to this club and do it for 10 months, 165 plus 24.95 times 10. So we can get our value that we need. Part B is to graph. You notice I didn't do a graph here. The thing I want you to think about is if I told you to graph this, okay, picture XY axis, you'd go up to 165, and then what? Yeah, because you have 24.95. So unless you have really good scaling, really good graph paper, anything you do is just going to be a sketch. So yeah, you can have an idea what this looks like. The line would be doing something like this, but I'm not worried about it. My MATLAB problems, these come out to be nicer numbers, so when you have to graph it in my MATLAB, it's better. Okay, so C, use the model to determine the total cost of a 14-month membership. Well, that's just saying estimate what C would be when t is 14. So plug 14 in for t, and try that again. So I'm going to replace the t with 14, $514.30. The next one is a little more complicated, but not much. Remember, in the first one, they gave us basically the slope and the y-intercept. This one's doing a couple things differently. At the close of 1995, there's 22,800 new auto dealers in the U.S. By end of 2012, this number dropped to 17,540. So the number dropped. Things are decreasing. My slope should turn out to be negative. Let d of x equal the number of new auto dealerships and x equal the number of years since 1995. That's important. We're not going to use the number 1995, and we're not going to use 2012. We're going to rescale this. This is going to become 0. So if this becomes 0, 2012 in this new system is going to become 17, because it's 17 years from 0 to here. So what I need to do is think about my 2 points. These 2 points right there, those are my coordinates, and I have to use those to get my slope. So what's happening here is I rescaled, used my slope formula, came up with approximately negative 309.41. And I know in class I said you typically want to keep these as fractions. When you're doing these applied problems, you're going to change it into decimals because most of the time you're going to be talking about money or something else that we need to have a finer control on. D of x becomes negative 309.41x plus 22,800. So I guess the question is, why is that 22,800? Well, you have to remember, we rescaled this, 1995. So if this is 0, 22,800, this represents my y-intercept. So this is the y value of my y-intercept. Now I can go through the process of finding the line using the point-slope form, but this works. Next part, use the function in part A to estimate the number of new auto dealerships in the year 2000. Well, the year 2000 is what from 1995? And you should be thinking 5 years. Cover this. So x is equal to 5. Plug in 5 for the t, or excuse me, for the x, and we end up with approximately 21,253. And this is an estimate. Okay, that's all this is. This model is just estimating what it should be. Hopefully we're close if it's a good model. Go down to the next page, part C. At this rate of decrease, when will the number of new auto dealerships reach or be 15,500? So we have to think about what this means. It means that we're going to replace the d of x with 15,500, set it equal to my model, and now you're going to solve for x. So you should be thinking, what would you do first here to get x by itself? Hopefully you're thinking subtract 22,800. And then simplifying that. Now I have to get negative 309.41 away from the x. So it's hooked by multiplication, so to unhook it, we're going to divide. So here we are dividing, and that's approximately 23.59. Notice how I went from equals to approximate. This is exact. I had to round to get that, and I'm rounding more because they want years, so 24 years. Well, 24 years from the year 1995. So when I add that together, that's going to be the year 2019.